Okay, so let's see. I'd like you guys to I guess you guys can see what I'm typing, huh? Can you guys see it on your side?
Yes.
Yep.
Okay. So what would that guy look like? Start up top. Propylamine. What's that guy gonna look like? That would be a common name. That is correct. 3. Okay. 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 So then here, this will be our amine. That's right. So 1, 2, 3. Okay. Good job. How about 3, 4 dimethyl, 2 ethyl, decane? Okay. So 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, it shouldn't be 2 ethyl. My bad. It won't be work out with 2 ethyl. You need a 3 ethyl at least, because 2 ethyl would make it not the longest chain. Does that make sense? Do you guys see why it can't be 2 ethyl? You don't see why it can't be 2 ethyl?
No. Why?
Okay, so if let's say I'm going to draw my ethyl in pink. If it was 2 ethyl, that means that the ethyl would be right here, right? And so, and then that would change the length of my chain, right? The longest chain. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that wouldn't work, right? So
Yeah.
Yeah. That's what happens when you pull stuff out of your butt. You know? Okay, so we know that it can't be 2 ethyl, so it has to be at least a 3 ethyl, which means this is the first carbon. This is the second carbon. This is is that changing colors? Is that right? Third carbon, fourth, fifth, sixth, 7, 8, 9, and 10. Okay, so then what am I going to do?
We're gonna put the long chain where it goes into 3.
Okay, so I'm going to put the ethyl chain on the 3. Is that what you're saying? So that's 1, 2. Okay, and what else is on 3?
Dimethyl.
So is it a dimethyl on the 3, or is it just a methyl? What does that look like? Okay, and then Okay, what about Tetra Pental chloride? Tet means what again? Is this a common name or sorry, is it a common name or is it a systematic name? An Iupac name. It's a common name. Okay. Tet means what? It really means the third carbon. So we're talking about the tertiary carbon. So it would mean the third carbon. But so what does that mean? Tet would mean, I need to go back over that for clarity. It is an inside carbon, yes. So we have, if it's pental, so it's a total of 5, but we'd have our first carbon here, our second carbon, our third carbon, and then the tet means it's attached to our our third carbon. So we'd have an attachment, 1, 2, 3. We'd have on that third carbon, we'd have one that's going to be going down, 1, 2, 3. So that's 1, 2, 3, 4. And then we have a carbon and a Cl. Okay. We'll go back over that, so we'll give us a little clarity. Sorry. So the third carbon. Oh no, I'm lying to you. Hold on. 1, 2. So tertiary carbon. So 1, 2, 3. That is wrong. So that's 1, 2, and then we'd have a carbon going up, a carbon going down, 1, 2, 3, 1, 2, 3, and then Cl here. Any different? 1, 2, 3. Second carbon, 1, 2, 3, 4, 5. Okay. 2, 3, 4. Tet met. 1, 2, 3, 4. Yeah, so it has a, because the tet is making reference to the tet pental is making reference to the hydrocarbon, not the hydrocarbon attached to the thing. So the hydrocarbon, the halogen is going to be attached to this, but the tet is making reference to that, this structure. Okay, iso isohexyl alcohol. Iso, what is the iso? Is it common or is it? It's common. And iso means same. So we have 1, 2. So a methyl, methyl, and then that will be 3. That would be, see, 1, 2, say 3, 4, 5, 6, and then an OH at the end. Okay, so iso, you have it's methyl, methyl, like branch. So it's kind of isolated, same. And then the rest of it would remain attached there. Are you guys getting it? Okay, so let's see. In heptal, straight chain, that's right. With the, yep, so that's 1. One, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7, and then Cl. Sec-butyl alcohol. Two, 1, 2, 3, 4. Okay, or you could have drawn it. I go backwards. 1, 2, 1, 2, 3, 4. Okay, so what does sec stand for? What's that? Second, what's that? 3? No, secondary. So it's like a secondary carbon. So 3, tertiary, secondary, and then we have iso, right? Did you guys get any of these?
I was
Ah, you-
having trouble with the tert one.
The Turk? Okay. Okay. So we'll go back over the Turk.
Yeah, the isoter and sec ones are killing me here.
Yeah, we'll go back over it. Yeah. Okay, so we'll go over it again. And that's why the Iupac is a little bit favored, right? Because then remembering the Turk, the secondary, and then you also know that they don't always hold up common names. So, okay, so let's see what we can do. Let me pull up the screen. I'm starving. Okay. Are you checking your hair, Gracia? Gracia? Does it look good?
Yes, I'm at the doctor.
Okay. Okay, so iso. So we know that when we make reference to the iso, you're going to have a methyl, right? And then it's kind of isolating. And then you're going to have the remaining parts of your carbon chain. So it's going to be the same on two sides, right? Iso, and then the remaining part, and then that's going to be attached to whatever group we are. Okay. So if we had iso, butanol or octanol, that's going to be two of the carbons are going to be associated here. So that would be here. Oops. 1, 2, and then the remaining carbons. So that on that on that second carbon, we'd have 1, 2, 3, 4, 5, 6. That should be 8. 1, 2, 3, 4, 5, 6, 7, 8. And then and it should be alcohol, octo alcohol, right? Okay, so it's just that branch structure. So when it's iso, you have this structure. Okay. Do you guys see that?
Oh, now I see it.
Yeah, just remember it's the branch. But again, this is for the common name, right? So if it's isopropanol, right? Okay, branch, okay? Isobutanol or isobutanol alcohol, right? So then it's 1, 2, 3, 4, and then OH. 4 carbons, 1, 2, 3, 4 carbons, OH. So it always has that little Y. Okay. Does that, you guys see that? Okay.
Yeah.
That's right. Yeah. So you have a little house, and then you have what's ever coming off that roof, you know. So yeah. So your little house, and then whatever comes off of it. Okay. So, but then that's 3 carbons that you have there. That's 1, 2, 3, and then you have to keep track of the rest, right? So butyl means we have to add 1 more, right? So, but those are all counted as part of the carbon chain. Does that make sense? Okay.
That makes more sense now.
Okay. And then sec. So here we have a methyl chain, and it's coming off of our second carbon. Okay. So then, and then whatever else you have. And so the remaining part of it, whatever else, goes here, right? That's going to attach to your R group. Okay. So if it's, let's say it is, what was it? Sec pent. Gotta think, because one of them will not work. So we'll say sec, if it was a sec pentanol. So this is sec but, right? So second carbon, and then you would continue down there. So if it was pent, that's 1, 2, 3, 4, and then you'd have another carbon here. So then this is your secondary carbon, and then it was amine, right? So then you'd have your amine group here. So if it was sec pental amine, we'd put our amine at this end. So you have the methyl coming down, and then you'd have these guys coming off for sec. So it's coming off the second carbon. Primary, secondary, in this case, right? Okay. In, sorry. So that's 1, 2, 1, 2, 3, 4. And then we'll have a methyl, and then we'll have an amine. NH. You're saying draw it like this? And let me get rid of the line. 1, 2, 3, 4, 5. Okay, so the methyl kind of group coming off, and then 1, 2, 3, 4 carbon chain added on. 1, 2, 3, 4, total of 5. So you're just coming off of the second carbon, right? So if you counted this as your first carbon, your second carbon, your third carbon, your fourth carbon, your fifth carbon. Or you can do it the other way, where you draw it this way. 2, 3, 4, 5. I get carried away. One, 2, 3, 4, 5. And then off your second. 1, 2. Yep, off your second carbon. Okay, so secondary, second carbon. Okay, and then terp. So this is where you have attachments. So you'll have your methyl or your iso, and then whatever else is remaining, and then you'll have whatever it's attached to. Okay. So 3, and then this will be like, let's say if this was methyl, I mean not methyl, pentyl as well. Say pentyl alcohol. So if it was tert, pentyl alcohol. So you'd have your iso, carbon, and then this is your center one. Then you'll have CH3. This guy would be CH2. And then this guy would be our alcohol, OH. Okay, so, and then the remaining part of it goes here. Okay, so that leaves a lot of limitations as your carbon gets bigger, right? Does that, you guys see that? Because as we get longer carbons, you're still going to have these structures. This guy, and then it's just, this chain is going to get longer. Okay. Questions? Are you clear? Is it better? Is it more hazy or what?
It's more clear.
It's more clear. Yeah. Okay. So let's go 15, 16. Okay, so we've already talked about what the N stands for. The N stands for unchained, right? So then that's just all of them. And then you have a terminal functional group. So anytime that you have the chain of your hydrocarbon and then a terminal functional group, that is N. But a lot of times they don't use N. They'll just use the term. They'll call it just butylamine. They don't always put the N there. But then you know that it's at the very end. It's understood to be at the very end. Okay. Where we would call this guy in terms of its normal nomenclature or systematic nomenclature, this guy would be, it would be 1-bromo, in this case, butane, right? Okay, So again, here we see, so this is your primary. Okay, so that is our secondary. So that means that we have something attached to our secondary carbon, right? So, and our tertiary. So tertiary means that we have carbon, we have a methyl group, carbon, and then we have whatever else attached, okay? So I should say, and this should be 3 attachments and then something else attached to it, okay? Is that clear? So in other words, so this guy would be considered the tertiary carbon, right? But you don't necessarily have to have a hydrogen here. Usually you have something coming off of it, to being the remainder of your chain. And then you'll have your functional group coming off. Okay. Okay, so we've already talked about how sec does not work, because then we start losing the concept of what sec actually means. It doesn't work for everything. We also talked about how tet does not work when we start getting into our larger hydrocarbons. So we're going to be limited to those smaller ones where this actually has significance to. Okay, because we could have different possibilities, right? So we have this one that exists and this one, and both of these would be considered tet, right? Because all you're doing is tet is making reference to that carbon being attached to hydrocarbon, 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 and then your functional, another functional group, okay? So we have multiple ways that we could be drawing that tet. Where in the case of pent, 2 of them are going to be the methyl group, the other one is going to be an ethyl group, right? And then in the case of butyl, all of them are all methyl groups. So if we did anything above that, it gets more complicated. It gets challenging. So we have multiple ways of getting the same thing, but they can't have the same name. Okay, does that make sense? So like that's, if we go back to sec, that's the same thing that's happening in the case of the sec, right? So both of these are examples of a secondary carbon, right? Because you still have that hydrogen, you have carbon and it's attached to a hydrocarbon and it's attached to a hydrocarbon, and then you have that functional group coming off of it. Okay. We've already talked about iso. You see the structure, iso, 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 iso. So iso is always going to be that corner room, you know, methyl on one side, methyl on the other side, and is attached to that middle carbon. Okay. Okay. So when we talk about systematic nomenclature or Iupac nomenclature, we always want to go with the numbering that is going to give us our functional group or the side chain, the lowest number. So if we take a look here, we could count this way: 1, 2, 3, 4, 5, 6, 7, 8. Right? So if we count it this way, then this would be on the 5th carbon. But if we count it this way, it's on the 4th carbon. Does that make sense? Okay.
Yes.
So always the lowest number system. Okay. We always want to make sure that we have the longest chain. Okay, so we're always going to end up with the longest chain. Let's see. Oh, and for the record, so I'm going to ask you on the exam why, let's say, those common names using iso and tet doesn't hold up for all hydrocarbons. So you need to know why it doesn't hold up and why we can't use it for, what was that? Yes, why they do not hold up. So that is definitely going to be on the exam.
Can you go over it again?
God, that sounds so familiar. Okay, so I want you guys to go over it. Tell me why wouldn't it hold up? Okay, because we have longer chains of carbon, we could split up that carbon chain multiple ways, right? So we could have that meth coming off of one, we could have an F coming off of another, and then we could have pentyl coming off another, right? So for the tet, you could have this guy being a pent, this guy being a meth, and then this guy being an F, right? But we can also have it being an F, and then all the remaining carbons on the other side, right? So at a certain point, you can no longer, let's go back to that structure. It's easier to see the image right here, okay? So after pent, because pent, you're always gonna end up with the same, you're gonna end up with 1, 1, and 2, right? For butyl, you're gonna end up with just 1, 1. Anything above that, you could end up with 3 here, you could end up with 4 here, you know, or you can end up with 4 here. You can end up with 3 here, 1 here, and 1 here, right? In this case, okay? And that would be the same thing, or basically this guy, 1, 1, and 3, 2, 2, and 1, right? So because, and these would both be referred to as hexyl. That's right. So that's why we start running out. Exactly. And they would mean 2 totally different compounds. They would behave differently. Okay. Their melting points would be different there. And that was the problem, that when they were using the common name, people would be referring to 2 different compounds. Okay. So once we get past 5, the pentyl, once we get past pentyl, this guy no longer holds up. Okay. And in the case of the sec, same thing. Once we get past 4, this guy no longer holds up. So sec only holds up to 4. So butyl is the most that you'll see sec with. Okay. Are you guys with me? Abby?
Yes, I'm writing down what you just said.
Okay. So logistically, because you can end up with multiple compounds that would have exactly the same name, that is the reason why you can't use them beyond sec, beyond butyl, and then tert beyond pentyl. Thank you.
So basically, if you ask us that question, we can just say that sec will only hold up to 4, so it can only hold up to butyl, and then tet will only hold up to pentyl, because
But
anything
why?
after that, it does, like the structure, it doesn't make, like the structure itself won't be compatible to what they're actually doing, kind of. I need to rephrase that.
Yes. Yes. That's right. So the answer would be, because you can create multiple compounds with the exact same name that would be totally different compounds with different properties, you can't use sec pentyl. Okay. Okay. You guys got it?
Yep.
Yes. I told you, I forget, man. After this class, I just like everything becomes a blur. I'm like, we talked about that already. I was already in chapter this morning. I'm like, oh, chapter 4. I already have my chapter 4 notes already planned out, putting in some questions because I feel we don't have enough questions in there to kind of keep you guys stimulated. So, you know, it's a work in progress. You guys got to bear with me.
This class is hard.
It's a lot of memorization.
It's
a
breaking
lot
my
of
brain.
Yeah, I wouldn't wish this on my worst enemy, dude.
I told you guys about OChem, but it's important. It is important, and you guys, it's the class is painful, but the labs are so cool. Like when stuff happens and you're calculating the melting point and all of this, and then you all of a sudden get the fragrance of your favorite perfume and stuff like that. You're like, yeah, that is really cool. And this is all because it's a hydrocarbon. We were just talking about you, boy. Thought you jumped ship. I'm like, man, did I lose another one already? Okay, so we've talked about the common name versus the systematic name. We know why there are limits to the common name and we can't utilize it the way we want to all the time. Now, this is also a problem because then that led to a lot of people using other names for bigger molecules, right? So then they get special names. And so that means that there's no real clear way of memorizing them. So you'll sit there and you'll type things or you'll type the chemical formula and 50 different names will come up, right? And you think I'm kidding. Seriously, I'll give you guys a link. I actually have to give you guys the link anyway because I think you guys need to utilize the databases that are available as well too. So, and so one chemical will have like 5 or 6 or 7 different names that'll be associated with it. And most of those will be a common name. And then you'll have the Iupac name. Okay, so the Iupac came to existence because of that, But there are certain ones that I want you to be familiar with in terms of using it because it's painful. And I want you to have a little bit of pain so you appreciate it that much more. Pain keeps you from making the same mistakes that we made when we were trying to name crap in the future. Okay. So the next thing that we want to talk about is we know that we use the longest chain, right? We always identify the longest chain. We always adjust the name according to the lowest number, right? And then the last thing that we want to make sure that we realize is that we're going to be using alphabetical order, right? So you're going to name things in terms of your side chains in terms of alphabetical order. So it depends on what it's in your side chain. Okay, so like for instance, here, this guy is longest chain. Is what in this case? 8. Okay, so that's where we got that octane from. And then we have 2 side chains. We have a methyl that's coming off of the 3rd side chain, and we have an ethyl that's coming off of the 5th side chain. Is that right? Okay. Or we could have an ethyl coming off of 1, 2, 3, 4, the 4th side chain, and then methyl coming off of the 6th side chain. Okay. You guys see that, right? So you see both of those options. So we're going to use the one that has the lowest number, right? So 3 gives us the lowest number. So we're going to use that one. Okay. Okay, so 3 is the lowest number. And then we do alphabetical order. So we list it in terms of alphabetical order. E comes before M, so E goes first. Now, if I had 5 methyls, right? Let me give you another. If I have 2 methyls, right? So then it would be dimethyl, right? We don't use that di, so we don't use those Greek prefixes to determine the order. We use the actual base, what it is, that root, the ethyl or the methyl. Does that make sense? So it's going to be based upon the root, okay? Yeah, you would always count. You're always going to count. It doesn't matter which way it goes because you're going to count to find the longest chain and the smallest number. So if you're counting from this way, it means the same thing as if you're counting from the other way, but you always want to find the smallest number. Does that make sense? Uh-huh. Mm-hmm. That's right. Yeah. Yeah. And so it doesn't matter. So if you're left-handed, you can draw it towards like as a lefty would. If you're right-handed, you could draw it as a righty would, and it would mean the same thing as long as you keep the numbering system correct. Okay. So it doesn't matter if you flip it yet. Okay, but it will later on. So, well, that's because the structure that we're talking about is going to be a little bit different in that. We'll talk about that in a second. Okay. So this is just telling us exactly what I just said. So if I have two methyls, right?
Mm-hmm.
Okay. So in this case, this is two methyls. So then we make that dimethyl, right? If there were three methyls, it would be trimethyl. If there were four methyls, it would be, you guys remember your, let's go through it because I know that you probably don't. Tetra, okay? So our Greek prefixes, di, tri, tet, I'm sorry, tetra. No, it's not sec. It isn't sec. They were just making reference to the other things that we're using. So what's after four?
Hepta?
Yeah. Then
I mean penta, not hecta.
hexa. Okay. 7. Hepta.
Heptam.
Octa.
Nona.
Minona. And deca. Okay. And so could you imagine having, well, you're never going to have like, you're never going to have octa, hecta, nana, so I guess you could, when you think about that, where you have a branch coming off of each of the carbon. So anyway, I'm just thinking out loud. Okay, so we know that makes reference to where they're located at. And again, we want to go with the smallest numbering system. So as soon as you see something there, that is going to be your smalling number system. Now, if you have options, right? We have options. Let's say we have an alcohol on one side and we have a bromo on the other side, right? And they both would be 1, okay? So then you would use priority. Who has the biggest priority? Alcohol is more important than the halogens. So alcohol would have priority over the other. Okay, and we'll talk more about that. I need to print out the priority list for you guys too. Okay. Okay, so we also know that it has to be in alphabetical order. Well, this is an E, but this is di, right? So what does that mean? We don't use those prefixes. Again, we do not use those prefixes. We have to look at what the base is. It's a methyl. So we're looking at methyl versus ethyl. Okay, we should look at what the group is. Okay. Okay, so this guy, it has longest carbon chain, 10, right? So that's our decane. And then it has, we go 1, 2, 3. On the third carbon, we have 2 carbon chain, ethyl, 2 carbon chain, ethyl, and then 4 4, 5, 6. Another ethyl. So in this case, we have 3 ethyls that we're talking about. So it's triethyl. So it'll be 3, 3, 6. Triethyl, 7, methyl, decane. Mauricio, are you there? Yeah. You have to think about it first. He's like, yeah, maybe, maybe not. Okay, so see if you guys got this, right? There's curveballs that you got. Okay, you guys ready? So let me go to the whiteboard. I'm going to draw the structure, and I'm lazy, so I'm going to use the skeletal structure, and then I want you guys to name it. Okay. So we'll start off with this one. We'll call this A. This one over here. Okay. So where should I start my counting from? Left or right? Okay. Okay, my left. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I could go 3, 5, 6, 7, which is going to give me the longest chain. 7 or 9. Okay, good. Okay, so we know that would be nonane. Okay. And then what's on my side chains? What are my, I have circle those in orange. So this guy on 2, and this guy on 3, and this guy on 5. Okay. So what are they? So I have 2 methyl groups. So how do I account for that? Okay, so I do the ethyl group first. So I'll do ethyl. Where is it located? 5. And then 2, 3. Is it methyl? Dimethyl. If I need to tell you how many I have. Running out of room. No name. Okay. Good. And to be correct, it would be. Okay, what about the next one? Let's do B. Let's do, this reminds me of Thor's sister, Hela, or Hela. So where would I start here? From right to left here. Okay, so we have, I can go difficult with you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so then I have okay. And then what are my side chains? What are these guys? Aren't these guys the same? So triethyl. And you said it was 4. So I just say 4, 5. Is that it? 4, 5, 5. Triethyl. Okay. And then what's left? 2, 3, 6. Trimethyl. Okay. Okay, everybody got that one? The peanut gallery at home, did you guys get that?
Yeah, well, I forgot 1 to count, but yeah, I got it.
Okay,
Yeah, I got it too.
okay. And then the last one. Oops.
A question. So when you add the long chains, do we also count them from there to, we only count the long chains as 1, 2, 3, and then forward?
Okay, you've got to repeat that one more time. Can you repeat that, Abby?
Yeah, so what I'm asking is basically when we add the long chains, do we count the long chains as well?
You always should count your longest chain. So I always number my longest chain, right? So that's, you're saying 1, 2, 3, 4, 5, 6, 7, 8, 9. My side chains, I don't necessarily count because I can count those with my eyes. That's 1, 2 carbons. So I only count my longest chain. Does that make sense? I only put the numbers on my longest chain.
Okay, got it. Because yeah, I was counting also the side chains, but okay, got it. Thank you.
Okay. So here, this last one, where are we going to start at? You saying here? Right? My other right? My other right. Okay. So that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that would be 8, this would be 9. Is that what we want it? No? Okay. Oh, wait, hold on. Oh, I like argument. We're getting heated here now. Is there gonna be a fight? 8, 9, 10. But if I count it, they're saying if I start it here, let's do that. Put it in green. We'll go 1. This is 2. This is 3. This is 4. This is 5. This is 6. This is 7. This is 8. This is 9. And this is 10. Okay, so if I go with the green, I have 2, 4. If I go with the orange, I have 2, 3. Yeah. So remember, you want the lowest number as possible. Regardless, the lowest number as possible. Alcohol, okay, so that's going to be different. So if the alcohol was here on the 2 and the alcohol was here on the 2, then it would make a difference because they're both on the 2, right? You would still, even in that case, you would still want it the lowest number possible, right? So if I had an alcohol here, it would still be, in this case, you would use this one as, but if you only, your functional groups, so your side chains, so right now we're talking side chains, right? Okay, so we're talking side chains. So side chains, there isn't any preference above each other. So they're all carbon-based. Now, when we start getting to the functional groups, you want to try to give your functional group the lowest number possible. And we'll talk about that later. But that's when we start talking about functional groups in terms of priority. Right now, the ethyl, the methyl, they're all considered the same class, So that's what you're asking earlier, right? So there's no priority in that case, right? You just want the lowest number possible, okay? So you want to get the lowest number possible. When we start getting to the functional groups, that's when it becomes a little bit different, okay? Because then there's a priority to it. There's a hierarchy. That's right. So if you guys, since these guys are all ethanes, right? They're all alkanes, right? Not ethanes. They're all alkanes. There's nobody has priority. They're all equal. Okay. Okay. So if they're all the same thing, they're going to be all equal, and you just want the lowest number. Okay. So when we start getting to the functional groups, that's going to be different. Okay. Okay. So then you're getting ahead of yourself. Yeah. It's okay. Okay. So let's go. Let's type. So what would it be? We have decane. And then you said how many ethyl? 7 ethyl. Two, 3, 6, and 9. Tetra methyl. Piece of cake. Okay. Okay, good. Okay. Yeah. I will mark you off if you don't have the dash, because 99.99% of the time they don't use the dash, right? So I won't hold it against you, but you need to be aware when you guys take the ACS exam, you want to be aware that it's supposed to be dashed. Although half the exam has the dash and the other half doesn't. But they make a point to mention the dash in one of the questions in the exam. So technically, yeah, this guy should have dash. Okay. But you'll see in reality, the only time that, and like on products, on product labeling, the only time that they use the dash is when they're making reference to the numbers and what it's attached to. Like, and I don't think it's because they run out of ink. Trying to see if they have that. Okay. Let's see. Slide. Okay. Okay, so we always know that, if you have numbers and you have a choice between them, then, okay. So if they're the exact same numbers, then you can play with the priority aspect of things. But if they're not the exact same numbers, right, you just want to go with the lowest number possible. Okay. First one with the lowest number, since they're exactly the same. These guys are exactly the same. So we're going to go with the lowest number possible. Okay. Good. Well, so, okay, so for instance here, this guy is 1, 2, right? And this guy is 1, 2. So this guy would be exactly the same thing, right? So in terms of priority, it's going to go in this case about our alphabet, right? B, because even though if you think about in priority, you would assume that chlorine is more important than bromine because it's down on the periodic table, right? But it's alphabetical, right? Bromine, B, C, right? So you want to give bromine the lowest number if you have an option. Here I have an option. I could give bromine 3, or I can give bromine 2. So which one am I going to give him? I'm going to give him that lower number because it's the one that I'm going to be mentioning first. Does that make sense? Yeah, because they're the same priority, right? Don't overthink it, okay? Okay. Okay, no, I just don't want you to overthink it. You're my overthinker. I have to remember. You are too. Yeah. Okay, so I have 2 overthinkers. Okay, so here I have the option of having ethyl or methyl. Who's going to have priority in this case? Why? What was that? Alphabetical order. That's right. Yeah. Yeah. Okay. No, I know you're not arguing. I'm not saying that you're my arguing. I'll tell you when you're arguing. Yeah, I recognize, but I think you overthink it sometimes. Yeah. Yes. Okay, because we're looking at the whole numbering system, right? Did you look at the whole numbering system? If we went the other way, it was 2, 4, right? Versus 2, 3. Isn't 3 less than 4? Okay. Do you see the difference between the two? So if you look at the name, and so the reason why this guy has 3, because these guys are both at 3, depending on where you started from. This guy's at a 3, this guy's at a 3, right? So if I started this way, this guy would be a 3, this guy would be a 3, right? And so 3, 5. Okay, so in this case, I have the option, right? So I'm going to go with the one that makes more sense, and that's using the one that's alphabetically, who's going to come first, right? That's right. Yeah. So you're always going to, yeah. So in situations like this, you're going to have a tiebreaker. In your situation, we had 2, 4, or 2, 3. We're going to go with the 2, 3 first. Okay. That's right. We're exactly the same. Yeah, but no, you want to look at it as a whole because you would have to look at the second one first, the next one that's coming up, right? So you have a 3 versus a 4, right? So you're going to go with that one because it's the next number would be, lowest number would be a 3. And then the next one's okay. Okay, so you're saying if I, okay, so even though it's 2, 4, 5, the 2, 3, 9 wins because it's 2, 3, okay, because you want to go with the lowest number first, right? Okay, does that make sense? So even though that other number is like, you still want to do it the lowest number. 2, 3 is lower than 2, 4. Okay. Yeah. Yeah. Does that make sense? So yeah, again, don't overthink it. Low numbers, lowest number, priority first if they're the same class, they're in the same group family or same group. Okay, now when we start getting into functional groups, we're going to make it a little more complicated, I promise you. Then you'll be like, I got to remember this. Okay. This actually gets, I think, into what we're talking. Okay, now we're talking about branches on branches. Hot mess. Okay, so so we're talking about branch to branch. Okay, so in this case, if we look at our system here, we have heptane. That's 1, 2, 3, 4, 5, 6, 7. Right? Okay. I have to count it because I'm blind. Oh, they don't. So 1, 2, 3, 4. Right? And if we went the other way, 1, 2, 3, 4. I guess it didn't matter either way. Okay, so on that fourth carbon, we have a first carbon. Off that first carbon, we have a methyl. This guy is an ethyl. Okay, so this guy gets 1 methyl ethyl, and that's on my fourth carbon on the main chain. Okay, so here's my ethyl. We find the longest chain, so the rule again applies. The longest chain in this situation, 1, 2, or 1, 2, right? So even if I go 1, 2, I'm gonna have a methyl coming off of this one, or I'm gonna have a methyl coming to that. Does that make sense? Okay, so again, longest chain off the branch, and then what's coming off it. Okay, so in this case, we have it's decane, and then this is coming off of our 5th carbon here. So off the 5th carbon, we count the longest chain, 1, 2, 3, or 1, 2, 3. Doesn't seem to matter either way, right? So longest chain is propyl, right? So then off the 2nd carbon, the first carbon is going to be the one that's attached to the main chain. So that's 1, 2, 3. And then off the 2nd carbon, we have a methyl group. So it'll be 2 methyl propyl, and all of that is off of the 5th carbon. Okay? You're lost, or you got it? It's a mess, right? Oh yeah. Okay, so here we have 1, 2, 3, 4, 5, 6, 7, 8. So 2, 3, 4, 5, 6, 7, 8. So off the 3rd carbon, or if I go the other way, 1, 2, 3, 4. So we start off, I'll let it finish doing what it's doing. So 4, okay. Okay, so this guy off of here, we will go and we have 1, 2, right? Or we have, actually no, that's 1, 2, or 1, 2, or 1, 2, okay? So either way, it's 2 would be the longest chain coming off of that. Does that make sense? 1, sorry, take that back. Let me put it in a different color, and it should be 1 at the one that's attached to the main chain. So that's the 1st carbon right here. This is our 1st carbon. This is our 2nd carbon. Or this could be our 1st carbon, and this could be our 2nd carbon. Or this could be our 1st carbon, and this could be our 2nd carbon. It's going to be the same either way, okay? So if this is 1, 2, then we have a methyl coming off of our 1st carbon in both. So we have 1, 1 dimethyl ethyl, and that one is on the 5th carbon, right? And this guy is on the 3rd carbon. Yes. The reason why they did the methyl Why do they put the methyl after the ethyl in this case? Right, because this guy is an ethyl as well, and it's further branched. And so they decided to put it before it, even though it's a methyl ethyl. They're both ethyls, so you want to put the more pure one closer to the end, and then the less pure one in the beginning. Does that make sense? No, it doesn't. Okay, so like, okay, this guy is still an ethyl, right? So right here is an ethyl. Because there's branching that's occurring here, we're going to make that, it makes it more of a priority. So it's going to go first. So they're ethyl, right? So they're both ethyl. So normally we'd say diethyl to kind of group them together. But this one has more complexity to it. So we're going to give it a priority. So we're going to make it go first in this case than the other ethyl, right? Now, if this was a propyl, right, then it would go back because then it's based upon alphabetical. So because this guy has the same root, that ethyl, then, does that make sense? So let's say instead of this being an ethyl, this guy was a propyl. Okay, because this is a P, right, propyl, we would put it closer to the octane instead of closer to the, okay? So even though it was 1,1-dimethyl propyl, right? That propyl is what we're going to be looking at in terms of the alphabetical. Since these both are ethyl, we're putting the other guy as priority. Okay? Are you? Okay. Yeah, well, I think I'm gonna have to give you guys a lot more examples. Okay, so this is where they start using those isos and stuff like that. So these are the common names. So this is a systematic name. These are going to be the common names, okay, of the same structures, right? So this guy would be called heptane, right? And then iso, because we know that they both have two methyls on both sides. So this guy would be called isopropyl heptane. This guy, again, it has that little structure, right? But now it's butane, right? So this guy would be called 5-isobutane, isobutyl decane, okay? This guy is tet because it's methyl, methyl, methyl on all four sides. And then it's attached to here. So this guy would be called 5-tet-butyl 3-ectaane. Really, I think it should be called ectyl. Got the L there. Okay, ectyl octane. Okay. Questions? You guys are just looking like, oh my God, he expects me to do. Got it? You feeling good? Simple? Yeah. I don't, you're not convincing me there. That was a, yeah. 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 Don't worry, I'll give you guys a lot of. Oh yeah. Oh yeah. Well, that's what it is. And we're just talking about, so far we've only talked about the alkanes, right? And we just kind of introduced some of the function groups. We haven't got into how they all play with each other. So don't worry, it'll be more fun. Okay. So I'm gonna go one more thing before I'm gonna give you guys a break. Okay. Okay, so oh, the other thing is, if you notice up here, they put the name in parentheses, right? So you want to make sure they include the parentheses. And so that tells us that you have a branch within a branch by using the parentheses, okay? Okay, and this is just showing us exactly the same thing. Okay, so this guy is decane, so we want to go the longest chain, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we could either go this way where we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Or we can go 1, 2, 3, 4. Right? So if we count it this way, 1, 2, 3, 4, we come across our first group, right? Compared to the 5 going the other way. And then that's 5, 6. Okay, so we have a propyl group coming off of the 4th, 4 propyl. And then this guy is, we want to find the longest chain here. 1, 2, 3. Right? You always start, the 1 carbon is always the one that's attached to the main chain. 1, 2, 3, or 1, or 1, 2, 3. Right? And then, so we'll use this as our next longest chain. So that's 1, 2, 3. So that would be propyl. And then we have 2 methyl groups. We have one coming off of the first carbon, and then we have one that's coming off of the second carbon. So it's 1, 2 dimethyl propyl, and then that all of that is coming off of the 6th carbon. Okay, Abby? Abby,
Yeah.
you got it?
Yeah, it's just a lot.
That's what everybody's saying right now. Okay, so this guy here is, okay, so we want to do the counting, shortest chain possible, or longest chain possible. What I was thinking. 1, 2, 3, 4, 5, 6, 7, 8, 9, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Longest chain, right? You guys see it? Okay. Okay, they just blew my mind. Okay, because they broke all the rules because this is a butyl, and then they put it afterwards. I need to confirm this because I don't think that's right, because it really should have been B before. This guy should have gone before this guy. So I'll have to confirm that. Good question. I'll confirm the answer to that. So me, if I were naming it, it would be, so then in this case, longest chain, shortest length. So 1, 2, 3, so 2. 2 would be the shortest. So then 2, 3, dimethyl. I'd put that in the back. And then I'd put, so this guy would be off of the 5th carbon, right? So then that's 1, 2, 3, 4. So then a 4 carbon chain is butyl. And then it's off of the 1, 2. So it's 2 methyl butyl. And all of that would be off the 5th. And again, I'd have put that first, and then I'd have put this second. But that's me. So I'll have to confirm this. Their answer and why it, because I think it's a typo. Okay. And I bet you that's exactly possible. So. Okay, so do you guys want to take a break, or do you guys want to start trying to
Can we take a break? My brain is almost fried.
Yeah,
okay.
you got me crying if you think I'm gonna keep going right now.
Okay, so we'll take a 10-minute break, bathroom break, mesa break, lunch break. Okay. I'll see you guys in 5. Oh, I'll take a cookie. I'm starving right now. I haven't had a chance. I've been trying to eat lunch all day. Ooh, a healthy cookie, protein cookie. It doesn't taste like it. Is this what they have, Mesa? You gave it to Jesse, and Jesse gives it to me. So I'm the guinea pig, huh? Oh. Okay. It falls apart. Okay. Okay. Uh, it wasn't as bad. Oh my gosh. It is really bad. It is really bad. Yeah. I like, and you're assuming it's chocolate chip. You can't make chocolate chip bad. Oh, that was wrong. Those are better. Oh yeah, I love those. Yeah. Thank you. You're trying to kill me.
Snacks better than the other day?
Yeah. The snacks are better. You guys, snacks better than the other day. Got it. Okay.
Dr. Henry, can I ask you something? I know it's off topic. It's not even for this class. It's for someone.
Hold on.
It's for another class.
Okay, hold on. Wait, hold on. I have one question here, and then I'll come back to you. This guy here, that's part of the, well, it depends. You've got to figure out which one is the main chain. Okay. Now, Abby, what was your question?
Never mind. I found it.
You found it?
Yeah, thank you.
That was bad. Yeah, it probably will. That's way too many. That's way too many. Sniffed it. It smells good, but it tastes bad. Yeah. And it looks good. I mean, you on the cover, you're like, damn, that looks like a really good cookie.
I remember I didn't like it. When you gonna read it? You gonna give it to me? Like, oh, he's gonna have it. Don't worry, read it. Right? Then you let me give it up.
I know you guys are having trouble with this, but you don't have to try to kill me, Oh, that's pretty nasty. Well, this is working after a while. I finished the cookie. It's trying to kill some of the taste. Yeah. That's, yeah, two. Yeah, sorry. I know it looks like one long line. Let's go with the first one. What's that? What is the largest carbon chain? So try Decane. Okay, so where would I find that at? Okay, right here. Okay, so 1, 2. Oops, let me use a different color. Green on green is not a good idea. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That will give you the longest. With the, you started here. Okay, so if we start here, I'm going to just add that red. 1, 2, 3. Then this is 4, 5, 6, 7. Okay. Anywhere else? Anybody else start anywhere else? From the top. Okay. So that's 1, 2, 3, 4. Okay. So this guy would give me 1, 2. This guy would give me 1, 2. This guy would give me 1, 2, 3. So we get rid of the brown. Ooh, this is getting good. Okay. Okay. Okay, so that's 1, 2, 3 here. That'll be my third one. Here, this guy is 1, 2. There's something on the 3. Oh, wow. This is getting good now. Okay, so then on the 4. So here, this guy would have nothing on the 4. The blue, right? 1, 2, 3, 4. Oh, I guess it would have something on the 4. 4. Oh, shit. Okay, so then what was that? There's a 5 and 6, but they both would have 5 and 6. So they both would have 4. Wait, 1, 2, 3, 1. Wait, 1. Wait, 1, 2, 3, and then 4. This guy would be 1, 1, 2, 3, and 4. This is a tricky one. So you guys technically could have used any one. Now we need some other means of separating them, since technically after that, they're going to be exactly the same, right? So if we would, yeah, but different names. So that's a hard one. So technically either one would be right, but we would have to try to figure out which one would be the most right, right? So in this case, we want to try to get, the rule is, it's the one with the most, I believe it's the most, okay, so this is gonna sound weird. It has the most side chains would be the one that would be the more right, okay? Which is weird, yeah. So then the top one would have 1, 2, 3 different side chains, where this guy would have 1, 2 side chains, is that right? 3. So I guess we're kind of stuck there. Because this guy, if we went with this way, we'd have 1, 2, yeah, 2 different side chains, where this guy would have 3. Okay, so then we would go with the top one. And I think that was the next topic that we were going to talk about. So, and I believe the idea on that, don't quote me because I can think of ways to make it really complicated. The idea on that is so that it would give you the simplest name. Your structures aren't as complex with more side chains. Okay, no, but don't quote me on that. Okay, but I believe that's the logic behind it. Okay, and then I'll show you the next slide since we didn't get there. It wasn't on purpose. This was totally on accident. But fortunately for me, I actually went that way. Okay, so what did you guys get? So we have 13. So then that's, you said tridecane. Okay. And what's that? Tetramethyl. Okay. And where are the methyls located at? 3, 5, and 6. Okay. Okay, so that covers those guys. So that's 2, 3, 5, and 6. Okay, now what about this crazy beast here? Okay, parentheses. 4, parentheses. One methyl propyl. Okay, so let me make sure I got this guy right. So we're on the 4th carbon. So that's 1, 2, 3, 4. 4th carbon here. This guy, what is the longest chain? You said propyl. So that's 1, 2, 3. Right? Okay, so let me put that in a different color. I'm gonna erase these guys. So, oops. Oh, oops. Okay, so here's purple here. Okay, so then this is the first one right here. This is 1. Then this could be 2. This could be 3. Or we can go, this is 1. This is 2. This is 3. Okay, which one would have the most side chains? Or would they have the same amount of side chains? So if this is 1, 2, 3, or 1, 2, 3. 1, 2, 3, or 1, 2, 3. How many side chains would this guy have? If this was 1, 2, 3, we're talking about the side chain of the side chain. So 1, 2, 3. How many side chains would it have? 1. So then if I go here, 1, 2, 3, I have 2. Okay. So the most side chains. Okay. So I know it doesn't make sense, but because you, okay, so then that's 1, 2, 3. Okay, so then it would be like you said parentheses, so that would be 4 parentheses. What is this guy that's coming off the first carbon right here? That's the first carbon. What is this guy? Okay. And so that would be 1 ethyl, 1 ethyl. I will eventually find the 1. Okay. And then what's coming off the second one? Methyl. So then it's 2 methyl propyl. That is a long ass name. No, that would be a test question. Extra credit.
I was gonna be like, no.
And E before M. And M before P, right? Alphabet, right? M before P. Iupac, Yes. Iupac are always going to have a lot of numbers. Common name is going to be iso, tert, but. Iupac, yeah, because that's what everybody is moving over to. They're trying to slowly phase out. The thing is, they've been trying to phase out. So Iupac came into existence in the 60s. So since the 60s, they've been trying to phase out common names. And you can tell that we still haven't, because what do we call the alcohol at home? Isopropyl alcohol. So yeah, but it'd be minimal. I won't make you do something like this in common name. That's like punishment. What's that? Really? Yeah. Nope, we want to try to do Iupac is the go-to, right? So Iupac is the go-to. We're trying to phase you guys into Iupac. Actually, it's part of the curriculum, you know, in chemistry, because like I said, they're trying to get all the old boys club out that's still using the ISO and stuff. Okay. Yeah. No, we put it, it's okay here. You're talking about right here, these guys. For these, for the methyl and the propyl? Or which, what are you making reference to going first?
So, like, because we have the 2, 3, 5.
Uh-huh. Okay, so we have the 2, 3, and the 5. And then we have this branch right here that's at the 4, right?
I'm
Yeah.
just trying to, like, how do you know when, because like, in one of them, it's a different.
Okay, it's based upon the base. So we're looking at the last name. So right here. Looking at these. Okay, M or P in alphabetical order. M. M goes first, so we'll put these guys first, then P goes last, right? Because all of these guys are on that P, right? So, and it's just because that one problem that we've had just a second ago that I have to go confirm. So far, it's still, that's a typo. And so I need to confirm that with the, like I said, one more look. Yeah. No, I get it. And it's a little confusing. Okay, is it alphabetical or is it, you know? And then we'll get back to that one where we have, where they both end with ethyl, right? And then we put the more complex one first before the other one. I need to confirm that too. So you had a question? Okay. Sure. We'll circle them. Thank you. Okay. Methyls. Yep. There's one here. There's one here. There's one here. There's one here. Okay. So, and you can see 1, 2, 3, and this is the 4th carbon. That's the 5th carbon. That's the 6th carbon. 2, 3, 5, 6. So it's on 2 second carbon, the 3rd carbon, the 5th carbon, and the 6th carbon. And then you have one that's way over here with the branching of. Okay. Okay, so let's see. Let's do this guy. Okay, longest chain. 9. Which way? Right to left or left to right? Okay. 2. Okay. Good answer. 3, 4, 5, 6, 7, 8, 9. Yes. Oh, okay. Okay. So on the 4th, what is our chain here? Okay. So we have 1, 2. So that's an ethyl. Okay. So start typing out this name. So a 9 carbon chain. No name. And we have on 4. What am I going to do for what? Parentheses. 1 methyl ethyl. It sounds like a joke. Was that? Yeah. Okay. Then five, 2, 2. Dimethyl. Propyl. So let me make sure I understand this. So you guys said that's 1, 2, 3. Okay. Okay. Questions, concerns, Kool-Aid? How's your brains doing? Feeling good? Okay. Okay. Ready to move forward? Oh, there's a question in the chat. Fried like eggs.
Yes.
Her brain is fried like eggs. Okay. Okay. So we've already kind of talked about this part. Okay, so when you have chains that are the same length, you go with the one that has the most substitutions or the most side chains. Okay, so this guy has 2 side chains compared to this guy only having 1 side chain. Okay, and again, I believe that's because it makes it a little bit easier. Although this is a crazy side chain, right? Because it's the iso pro. I may do both, or I may give you the drawing and then you get the name, like we've been doing both. Yes, we will practice both. I will start giving you some names as well too. Yeah, but I wanted to get a little bit more underneath your belt. I think it's easier if you have the structure and then do the name. Problem is that when I don't see the structure and I try to make up the name, I make those mistakes. Don't worry about it. I got you. But I usually correct them afterwards. Okay, so cycloalkanes. Cycloalkanes are just that. They form circles. So this guy is cyclopropane, 1, 2, 3. Okay. This guy is cyclobutane. This guy is cyclopentane. This guy is cyclohexane. This is what they look like. Okay. What was that? Oh. Do you have a cyclohexane stamp? Is it an OChem? Is it an OChem stamps? Oh yeah, that's right. You did show me that one. Yes, yes, yes. Ah, perfect. So you can get your benzene ring in easily and not make huge mistakes drawing them. Okay. So if there's only a single substitution, you don't need the number, right? Or you could just say, this guy is 1, because it's always going to start on the 1 carbon chain, okay? So this guy here is called 1-cyclobutane, okay? 1-cyclobutane, you have your cyclo ring, your butane, cyclobutyl pentane, and then you have your pentane ring. Now, this guy is the side chain, this guy is the main chain. Why? Because it's longer in length. That is exactly it. Because it's longer in length, sorry, I keep staring into the light. Because it's longer in the length, it gets the last part. And so then we call this guy butyl as a result of that. It's on the first, that will be the first carbon. So it tells me where that it is on the pentane. It's not on the second carbon. Otherwise we'd say 2, right? Okay, now this guy is ethyl cycle hexane. So why is this guy ethyl cycle hexane instead of cyclohexyl ethane? Is it because E becomes over H? Nope, it has nothing to do with alphabetical. Yes, the cyclohexane has 6 carbons, where the ethyl has 2 carbons. So this would be my longest chain. So it gets the back. Does that make sense? Yeah. It's like a trick question, huh? So that you may see on the exam, huh? Okay, so this guy is Methylcycle Pentane. Okay, and so we can clearly see why it's called Methylcycle Pentane, right? Because the methyl is the smallest one. Okay. Okay. So if there is 2 substitutions, we're going to go with alphabetical, right? Because these guys, again, are the same, they're on the same plane, right? They're all alkanes, okay? So alphabetical, methyl becomes before propyl, so methyl becomes the 1, then the propyl would be the next number, 2. Ethyl before the methyl, because ethyl is an E, methyl is an M, so ethyl becomes 1, and methyl becomes 3. Okay. Okay, so the numbers can start anywhere, technically, right? So I could have started here, I could have started there, I could have started there, right? But since ethyl is lower in the alphabet than methyl, the number is going to start on our ethyl. So that'll be 1, 2, 3. If I decided to go the other way, 1, 2, 3, right? That'll be 4. That would give me high numbers. Okay, so you always want low numbers, right? Okay, so your 1 is always going to start on the one that's first in the alphabet, if they're all alkanes. Okay. Yeah, so the cycle out. Yeah, Well, you're gonna, well, because this is the main, that is the main group, right? That is the longest carbon chain, right? The cycle is a pentane compared to these guys, which are all, there's only 2 carbons, right? 1 carbon, okay? Here, this is 1, 2, 3, right? This is 5, so we're gonna, this is your main guy, right? So that's cyclopentane, okay? And then we would start on the methyl being 1, then that's 2, right? Because if we went the other way, then that would be 5, right? We don't want that. Okay, here, 1, 2, 3, 1, 3, dimethyl cyclohexane. Are you guys there? Okay, let's see. What was that? You think? Okay, so let's see. Let's do. Sorry, 1, 2. I know it doesn't look good. I don't got a stamp. Well, maybe I do. Hold on. I do have stamps. What was that? They're shapes, they're not the ones I want. Yeah, yeah. There's circles, there's squares, and there's a triangle. Okay. Oh, she rubs it in. You want me to just spray it on the board? Okay, so we'll do. There we go. Make it complicated. Okay, so what do we got here? Okay, so we have cyclopentane. Okay. I have 2 methyl groups. Where are they located? From where? Okay, so you said you started numbering from here? Okay. Okay, so then that will be this way. Okay. 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 And where's the ethyl located at? It's 1. Okay. And then you said 2, 2. But is it a methyl propyl or is it a methyl and a propyl off the 2 carbon chain? No, would it be in parentheses? Yeah, so the propyl will be its own group. Okay, so we'll go towards the end. We have 2 propyl. Okay, and the methyl, 2,4-dimethyl. That's right. Okay, so let me see if I can explain this. Oops, that's too small. There you go. Okay, so here, because this is on the main chain, we have a methyl on the second one, and we have a methyl on the fourth. So we take that into account by saying dimethyl. The only time that you use methyl propyl is if the methyl chain was hanging off of the propyl group, and it's not doing that. So. Okay, makes sense? Good. Okay. Okay. What's up? 414. We're going to get one more slide in. Don't try to get out early. One more slide. And I'm trying to pump this in. This is a long chapter. We're only on slide number 35. There's 113 slides in here. So.
Oh my God, I'm already dying.
Okay. So here, again, we want the lowest numbers, right? And then we want to try to get it. So like in this case, we have numbers that are on, let's say, substitutions. Okay, so how can I say this? Okay, because we have substitutions that we can decide where the number goes, right? So I could have it go here, or I can go here. We're going to use the one that has the same low number substitution first. So this guy could be 1, this guy could be 2, or this guy could be 1, or this guy could be 2, right? We're going to go with this guy being 1 because you have 2 substitutions there, okay? Or you have 2 branches or 2 groups hanging off it. So this guy is going to be 1, this guy is going to be 2 because it has 2 methyl groups, okay? Where this guy only has 1 methyl group. So does that make sense? So you want the low number to go to the one that has, if you have a choice to where it goes, you want the low number to go to the one that has a low its number, or your double substitution is. Okay? So here, this guy, they break my rule? So, oh, no, they didn't. Okay? So here, if we went ethyl, 1, then we go 2, 3, 4, right? So that would give me a 1, a 3, and a 4. Okay. If we went here, 1, 2, 3, 4. Okay. So then that would give me 1, 2, which is lower numbers. Okay. And then the last one would be 1, 2, 5, right? Let's see if I can do that one. I should do them in different colors. I'm sorry. If I go 1, 2, then it still didn't do different colors. 3, 4, and 5. Okay. So then that would give me 1, 2, and 5 compared to 1, 2, and 4. So the 1, 2, and 4 gives me the lowest numbers possible. Okay. So then, even though if we have a choice, we want to go alphabetical, right? But we want to make sure that all the numbers are the low numbers, the lowest numbers possible. Does that make sense? Okay. Yeah, that's right. When they're all alkanes, yeah, when they're all alkanes, yes. Yep. Yeah, let me check. I might have. Let's see, does that give me the lowest number? No, not because there's two side chains. If they're two of the same substitutions, like, so these guys are both trimethyl, right? Okay. So like here, these guys, so we have the option of making this guy, since these both are both methyls, right? Not trimethyls. These are both methyls here, right? So I have the option of making this 1, or I have the option of making this 2. So if I have an option between, so this guy would be 1 and 2, where our other one was based differently, right? It's a methyl and a propyl on the same one. Okay. So since I had a methyl and a propyl, then that 2 substitution isn't the same. It isn't the same concept, right? Because these are exact. Do you understand what I'm saying? We are going for the lowest numbers. Did they get the lowest numbers? Did I not give you the lowest numbers? 1, 2, 3, 4, or 1, 2, 3, 4, or 1, 2, 3, 4. Let's see, 1, 2, 3. Yeah, you got me. You're right. Yeah. So we would have to start at our propyl methyl, because then that would give us, we would end up with 1 propyl, and we'd have 1, 4 dimethyl, and then 2 ethyl. So you're right. So it'd be 2 ethyl, 1, 4 dimethyl, 1 propyl. Because then I'd have 2 of them at 1 and 1 of them at 2. You're right. I eat crow. Okay. Let me throw it back up, because then it'll make more sense if you see it. So we had a methyl and a propyl, and then we had ethyl and methyl here. Okay. So if we started this guy with, use different colors, hopefully it works. 1, 2, 3, 4. Okay. Or we could have started at, we started this guy, that'll be 1, 2, 3, 4. Red, and then, or we have the one we did, which is 1, 2, 3, 4, right? Okay, so this guy would give us 1, 2, and 4. This guy would give us, if we started here, that would be 1, 1, I screwed up, that'll be 2, that'll be 3, that'll be 4, right? So we have 1, 3, and 4. And then we have 1, 2, and 4. Okay. And then we have, if we started with this guy at 1, we have all of these guys. You'd have 2 of them at 1, 2, you have 2 at 1. And then this guy at 4. Okay. Where if we started with this one, 1, 2, we'd have 2 of them at 2 and 4. And if we started here, that'll be 1, 2, 3, 2 of them at 3 and 4. Okay. So this guy is bigger number, so we wouldn't use that one, right? Because it's 1 and 3. These guys have the same number, but you have 2 of them that are starting out at 1. And so this would be the better choice, because you have 2 of them with the lower number. Okay, so lowest number outbeats alphabet. Okay, and that's the other thing that, so lowest number beats alphabet. Now, if we have a choice between the two, alphabet, so lowest number first, then alphabet, and then, okay. You just wanted me to stop on the slide. That's what it was. Pause me. I see how it is. I see you. Okay, so we'll finish this up on Monday or Tuesday, or maybe not.